Welcome back for part 12 of the narrated series that sits alongside the GCSE Science Sprints. In this video we're going to be going through the exact same exam question but just talking through each step of the process and why we're doing it. At first glance this may not appear to be a particularly challenging question, but on closer inspection you're going to realise that actually in order to answer it we're going to need a variety of different equations, including some rearranging, and also we're going to need to do some unit conversion. And that's why this is an extended response question, which could be worth quite a few marks in the GCSE physics exam. So in order to calculate specific heat capacity, there is only one equation on the equation sheet that includes that term, but that also requires you to know a change in energy, a mass, and a change in temperature. And although we have the mass and the change in temperature, we don't have energy. So first we need to think about what information we've been given and how we could use that. In the circuit diagram, you're given an ammeter and a voltmeter, which measure current and potential difference respectively. So if I have current and potential difference, I can put these together to calculate power. So power is current multiplied by potential difference, in other words, the 2 amps from the ammeter multiplied by the 12 volts from the voltmeter, and that gives me a total power of 24 watts. What that means in real terms is that every second the circuit is transferring 24 joules of energy. So then I can use my second power equation, which tells me that power is energy over time. And if I rearrange that, then energy is power times by time. But there's another trap here. I've been given the time as 1 minute, but I don't need time to be in minutes, I need it to be in seconds because those are the standard international units which I need to use for all of my physics equations. So I'm going to convert that 1 minute to 60 seconds, and then I can calculate that the energy will be 24 watts multiplied by 60 seconds, which is 1440 joules. Now I have the change in energy and the mass and the temperature change. So I'm going to write out my delta E is mc delta theta, just so that I've got that equation there, and then I could either substitute these numbers in or I could rearrange. So based on all that, I know that the specific heat capacity is going to be the change in energy over the mass multiplied by the change in temperature. But you have to watch out for the mass, because again, we've been given some incorrect units here. We've been given it in grams and we need it in kilograms. So you need to divide by 1,000, otherwise your answer would be 1,000 times too big. When I then substitute those numbers in, I get an answer of 576 joules per kilogram degrees C. Thank you very much for watching, and I really hope that you're finding these commentary videos useful as an addition to your GCSE Science revision. If you are finding them good, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.